Okay, on to the lesson for part two here on upwelling, El Nino, and coral reefs. We're going to be measuring some coral growth here. Obviously, we can't have live coral, nor do I have it in the classroom either, but we can use pictures and some graphite reproductions to do that. So here's what you got to do. Open up the file name Student Activity Worksheets, open up handout 1, S1 I should say, and open up the file named handout S2. You get those three things done and you're going to have everything set in front of you. And I'll pause here for 1 second to give you a second to do that. Okay, so hopefully you've got those handouts taken care of. And then we're going to be filling in table S2 on page 3 of the Student Activity Worksheets, and I'll talk my way through how we're going to do that. All right, so what we're going to be doing here is ultimately we're going to be taking reproductions of coral obtained from the Gulfs of Cherokee and Panama to measure their growth during an El Nino season. So in 2016, divers went down, they made molds, like plastic molds, of a couple of different growing corals, and then they brought them up. They made 3D reproductions of them, and then it so happened that that year was an El Nino season. And so in spring of 2017, they went back to those same exact corals. They're marked off. It's a research facility. And they made new molds of them. And so we have pictures of those molds that we're going to be using. The Gulf of Panama, remember that's the upwelling Gulf that typically has upwelling. That one is in handouts S1. And then Gulf of Cherokee is in handout S2. So remember, Gulf of Panama is typically upwelling. During an El Nino season, it doesn't. All right, so I'm going to get to the measurements here in a second, but they use this picture to tell us to go from the base to the very tip. Make sure you're making that measurement. Just ignore this like plastic putty here. That's really meant to just get that thing stuck onto there. Okay, so I'm going to go through these tips really, but ultimately this is really kind of hard to print off or to do without printing off. But here's that student activity worksheet. You're going to slide down to table S2, and then I'm going to fill in here to start out with. So here's the Gulf of Panama, and the coral ID is 1L. So Gulf of Panama stuff, remember, is in handout S1. So that's in handout S1. And if we slide down here, you can see that they've got different examples here. And they start in the spring of 2016, and then they show you what it looks like in the spring of 2017. Again, recall here that all we need to do is write down the height or the centimeter height of these things in 2016, and then again in 2017, and then show its change, like how much did it grow, okay? So we're gonna look at coral ID 1L, which is on S1 here. Now, if you have a printer handy, it's pretty simple to print these things off. I've got a color printer, so I use that. So I printed this thing off, and I've saved these for a couple of years now to use with class. But you guys may not have a color printer, nor do you wanna use it. So there's another way to do this. So if you print it off, let me just say if you print it off, you just use this and you use a ruler. You can use any ruler that you want to, but we're going to be reporting this in centimeters. So if you want to start out in inches and convert it, that's fine. But I've got like a little clear plastic ruler here, and I'm going to measure these things out. So I can go ahead and do that on a piece of paper. If you don't have that, what you can do is you can use your own piece of paper, and you can mark the screen that's sitting here in front of your face, and you can use the little the guide that they give you here, kind of this measurement, right? So they tell you basically, here's the scale, is that's going to be 1 centimeter. So what I'm going to do is I'm going to take my piece of paper here, and I'm going to hold it up to the screen, and I'm going to make marks on here of where that centimeter actually exists. So I'm going to make marks on my piece of paper. That's 1 centimeter, and then I'm going to move it over, and I'm going to do another centimeter. I'm going to move it over, I'm going to do another centimeter, and then move it over, I'm going to do another centimeter. Move it over and do another one. Ultimately, what I've done then is I've just made a really simple, that's all we need, a very simple way to mark off these things. And then you can use this directly on your screen. So you can use this as, well, if that's the scale, then I go ahead and do that. The only glitch here is that you can't change the zoom that PDF file is in. So just make sure you stay in the same zoom, and then that will be consistent and you'll be able to get those measurements. So I've gone ahead and I've measured this first one out here on the piece of paper with this little plastic ruler, right? So I have measured this thing out, and I would fill in that 2016, 1L was 5 centimeters tall. And then in 2017, it was 8 centimeters tall. And the change in height would be 3 centimeters. We're going to do that. You guys are going to fill in for 4L, 6L, 10D, 26L. You're going to get these changes. You're going to get a mean average growth rate then. You're going to have a set of data here of 5 things. Divide by 5, add them up, divide by 5. That's going to tell you your mean growth. And then you need to calculate standard deviation. Now it's pretty simple to do standard deviation on a calculator. Some of you are pretty adept at that. If you don't have that, you can just simply look up standard deviation calculator online, which I've done here, and you can plug in your 5 numbers that you have. So this is just what it lands on right now, but you guys will have 5 numbers here for the change in height. 1, 2, 3, 4, 5. Plug those in, it will tell you your standard deviation. What standard deviation tells you is any given number in a data set should be off from the average by about that much. That's what you expect. So when we go back to here, and I click present, standard deviation on here, these little bars that go up and down on the charts, those are standard deviation bars. Many of you have seen them before, but you're really not familiar with them. And I think it's time that we pick up the scientific literacy here a little bit. So what we can see here is that like this bar that says inside and is about growth of mold on something or other. So it looks like the average here was 34, somewhere around 34. But notice that there was a deviation. There was a bit of a wobble in the data. So it means that any given number in that data set could have fallen actually between here and here pretty reasonably. Shorter bars mean less deviation, means that the data set was actually tighter. So that's what those bars mean, okay? The last thing, I'm going back one step here. The last thing is that scientists like to write things like X year -1. Remember year -1, or like if you had a variable with a -1 exponent, you put it on the bottom of your equation. So it's X over year or X per year. So when you see things like year -1, it means per year. If it says M -2, it means per square meter. Okay. So what we're doing here is just going back to this data table. This says mean annual growth rate, centimeters, year -1. That means centimeters per year, which you should just get from here. Okay. So you just get your average from there. That's your growth rate per year. All right. Do that for the Gulf of Cherokee, which is this handout S2. That's going to have all your samples in there. And then you're going to finish that thing out. And that's pretty much it for day 2.